Okay, hi folks. Great to see you all. I'm Chris Saxon, part of Stephen Feuerstein's Oracle Developer Advocate team and the traditional answer team for Ask Tom. So it's my job to help you get the best out of Oracle database and hopefully have a little bit of fun whilst doing so. So with that in mind, today we're going to be answering some of your SQL questions in today's SQL office hours. We've had a couple of questions come in advance, so we'll jump into those because there's a lot of things we can talk about related to them. As always, if you've got any questions yourself, just put them in the chat. I'm keeping half an eye on it. Let me know if you want me to clarifying anything, go in more detail as we go along. And you don't. At the end, we'll probably have some time for some general questions if you've got those as well. So let me bring my slides back up. Hopefully you can see those now. And let's get going. So first up, we had a question come in that was related to Flashback Data Archive. So person had enabled it on a table so they could get some audit information. They were running a query with a bit like this. There's a whole bunch of stuff in there. But one of the key things is they were calling this DBMS Flashback Archive gets this context procedure, function I should say. And at that point, they were getting an ORA 1405. And they were like, well, what's going on? Why am I getting this? So before I answer that, I just wanted to give you a kind of a bit of background into what Flashback Data Archive is and how it all works. And to answer that, first I'll start talking about something which a lot of businesses care about, certainly all financial ones, and that's kind of fraud. So this is where people either internally or externally are manipulating the data to do things they shouldn't do, or maybe they're carrying out transactions that they shouldn't. So this is something a lot of businesses care or worry about, because it's screwing the business and the customers out of money. So this isn't good. So some of you may remember or may have heard about a year or so ago, there was the LIBOR exchange rate fixing scandal, which broke here in the UK. So some traders were found guilty of fixing exchange rates so they could profit out of currency exchange and things like that. And so what I want to do is just kind of imagine hypothetically what someone might have done in this scenario. So we'll imagine someone has managed to get hold of the master database which holds exchange rates. I'm not sure one of these things exists, so just stick with me here. But let's just imagine that somehow you've got access, or a trader has got access to the master exchange rate database, and they want to look to make some quick profit. So what they're going to do is set the US dollar to the British pound exchange rate to 1. So traditionally, it's always been about 1.3 dollars to the pound or something like that. And so they're gonna set that 1 to 1. Sorry, you just making some noise. I'm just gonna make you quiet there. George, yeah, thanks, George. You switching mic off. Okay, so then we're going to set the exchange rate, and then they're going to sell a whole bunch of dollars, and then they're going to quickly change it back again so it's the correct rate. And then at that point, they're going to get back on the phone and then buy the dollars back again. So, and this, they've just done a very brief transaction, and they've made a huge profit here because basically they've exchanged pounds to dollars 1 to 1, and then bought them back again at a rate of 0.7 or whatever it is pounds to the dollar, and so they've got 300,000 pounds profit or something. They may have been able to make a huge profit. Now, so this isn't a good situation where people are able to manipulate data. Now, as I say, in the real world, something like this probably doesn't happen with exchange rates, but it could happen with any kind of financial data in your company. There's always someone who has access and is actually allowed and authorized to change prices in your application, in your system, who can set the customer's prices. And if they're able to go in and manipulate that so that they can get their friends discounts or get themselves discounts and so on, and they, they can profit out of that. So this isn't good. Now, there's various techniques, various things you should do to help prevent this, but one of the key things is helping detect it. A lot of fraud customers are always going to be able to carry out. So what do you do? How do you detect it if it happens in the background? Or how do you detect it? Well, you need to see all the changes that have happened. We've run an update, and that changes values in place. So as soon as we've got that new price, well, we've lost our history. We don't know what the prices were before. So this isn't good. you want to be able to see a complete change history. You want to see everything that was active at a particular point in time. So how do you do that? Well, some always person says we need to audit it. Every time someone runs insert, update, delete against our tables, our financial tables, transaction tables, we're going to audit it. So we've got a record of exactly what happened. So if someone's fiddling with the data in some way, we can look back and see who did it, when they did it, that kind of thing. Okay, and really common requirement. And what's the obvious solution? Well, what's the answer to this? Well, the obvious solution that a lot of people go for is let's just create a whole bunch of triggers on these tables. Every single table we want to audit, we'll create a corresponding underscore, hist or underscore ord or something like that. And every time there's changes on that, we'll have a trigger which captures the changes and puts them in that audit table. So this is easy and it's obvious, but there's a lot of problems with it. Now, some people kind of go, triggers, performance overhead. That's not the thing that really concerns me with this. The thing that really worries me with this is that it's an ongoing burden of maintenance on the development team. The developers have to remember that every time you create a new table or change an existing table, you need to create the new trigger or update it. And this is the kind of thing that tends to get lost in the mists of time. I've worked on systems where someone 5-10 years ago implemented a complete audit solution, and then for whatever reason, as the developers on the team changed, that information was lost, or people didn't realize they were supposed to keep these triggers up to date. So you can end up in the weird or scary situation where you got a whole bunch of triggers, a whole bunch of tables with none of these auditing triggers. Or perhaps even worse, you have got the auditing triggers there, but they're missing half the columns. And this is particularly a problem because, generally speaking, audit information is not required for the day-to-day functioning of your application. You've got no audit, everything generally works just fine. It's only, if you're investigating a bug or the auditors come in and want to see your transaction history, all your changes, that you go and look at it. And this can be weeks, months, some cases even years down the line. So you can go a really long time before you realize that all this audit information you thought you were capturing, you don't have. And then you're in the awkward situation trying to explain why things happened to some auditors, financial commission, whoever it is, and potentially the company is going to face fines as a result of this. So this isn't good. You want to be able to ensure that you can keep things up to date. You can always track exactly what's changed. So now, some of you may be aware there is a way to see changes to your table over time with Oracle's Flashback query features. So you can run a query like this. You can do as of, timestamp, or SCN to get the table at a particular point in time, but you can also do the versions between two dates or two SCNs and find all the changes that happen to the table in that period. And this is something you've got as long as you've got Flashback enabled, which it generally is on modern databases. So you can use this to query back and see the changes over time. So this is great, right? Well, why don't we just use this? Well, the problem with this is it's using your undo table space. It's looking back in the undo to see all the change history to be able to reconstruct past history. This brings about a couple of problems. First up, your undo table space needs to be big enough to accommodate all the changes. So if you want to have a year's worth of history on there, for example, potentially you need an absolutely colossal undo table space to support this. It's not the kind of thing your DBA is going to be very happy about. But even if they do agree to this and allow you to have, a year's worth of Flashback query, well, there's still another problem. There are various things which can break this. Particular note, if you restart the database instance, as soon as it restarts, then your undo's lost. So anytime you need to reboot, that's it, your Flashback query is gone. Also, there's various types of DDL will break this. So you cannot flash back to before them. So you altered your tables in certain ways, you can't see the row changes before that. So this isn't good. So if we want to see all the changes this year, chances are we're not going to be able to do it using standard Flashback query. So, so Swarmy, sorry, I just see you've got a question come there. I think we're going to have to come back to that later. Say that to the end. I'm going to go through all these things. We'll discuss that a bit later. So we need Flashback. So this is where Flashback Data Archive in. What it allows you to do is have a permanent store of your data. So instead of looking in undo table space to see this information, what we've got is some tables in your schema, or it creates some tables for you to store this information. So how do you do this? Well, first thing you need to do is create the archive. And this is where telling the database where to store the information. And you can set a retention period. So this can be weeks, months, days, weeks, months, or years. This tells the database how long you keep to guarantee to keep the information. So here we're saying we want to be able to have 1 month of history, change history for our tables. So we create the archive. The next thing we need to do is actually enable the tables to do it. So we alter the table and we do, set the flashback archive to whatever we just called it, change history, whatever your appropriate name is. So now we can go back and do this and run this query, and we'll be able to get all the changes since we first enabled it. So there are also these whole bunch of versions pseudo columns available, and these capture a whole bunch of information about what's going on. So the operation, insert, update, delete, when the row is active, the start and the end time, the start and the end, SCN. So there's a whole stack of information available. So this is something that's actually been around for quite a while in the form of an option. It was originally called Total Recall. I think we might have called it something else in the meantime. As of 11.204, Flashback Data Archive is included in your Enterprise Edition license. So as long as you're on 11.204 or above and you've got Enterprise Edition, you can use Flashback Data Archive, and it's just part of the normal database features. So that's kind of a bit of an overview of what Flashback Data Archive is. So what I want to do now is I was just going to jump into a little demonstration of how it works, and we could also discuss what's going on, why that person potentially, possibly why they were getting that old 1405 error when running the query. So we've got a table here, like an address history, and put some data in there, and I'm just recording some information about how I've changed. So let me just query that so we can see we've got 2 rows in the table at the moment. So I will create the Flashback archive and put the table in it. So now what we can do is use this versions between SCN min value and max value. So this will find all the changes available for this table and all the history that we have for it. So we do that and we can see, they're all blank, they're all null. Okay, well, why is that? Well, we haven't enabled Flashback Data Archive when we first created the table. So there's a whole bunch of changes in here that were before we actually enabled FBDA. So, okay, what's going on? So if we look now at these kind of Flashback Archive syscontext calls that the question user was asking about, if we try and run those, well, we get the fetch column value is null error. So if you can see that down there, I'm not sure that's worked properly. So you can see that. And so the problem here is this version's pseudo column is null. It doesn't have a value. Unfortunately, we haven't been great about our error handling here, so that it's kind of propagating out to say something a bit weird. So if you are in this situation where you're doing these versions queries and you're getting this kind of fetch column value as null, check whether these versions columns are actually populated. If you're fetching rows from back before you enable Flashback Archive for the table, chances are you're not going to be able to get the data. So that's one thing to look at. So let's just show what happens now how it should work, how it's supposed to work if everything's all fine. So we'll delete everything out and reinsert it, rerun the transactions basically. And now I will get the minimum SCN for the thing. And now if we rerun, I'll take these out to start with and paste that in. Oh, it's because, okay, let me rerun the whole thing. Let's start from the beginning. I think it's possibly because I had it set up beforehand. So let's see if we rerun that. No. Love it when demos work, right? What have I done now? Okay, who can spot what I've done? How I've messed this up? Let's see. There we go. So we've got our change history. What did I do wrong here? So we've got the error, got the changes, got all that. Okay, what have I done? And okay, so we're only getting one row in here, which is a bad sign. Okay. Let's check. Let's check what happens when we do this. Versions. Okay, I've missed something there. Sorry about this, folks. So any questions or comments on this before, while I just have a think about what's actually going on here? Got any questions or comments, just put them in the chat. Let me know what you think. You know, does this sound like a good feature, something you'd use? How would you use it? And so on. So let's SQL command not properly ended. Because that needs to go. I need to put the alias at the end of that. That's why. So that's null. Okay. All right, I'll try one more time. Try one more time. Set everything up. Let's look and see what's there. Reset everything. Alter the table. This is going to break. We'll delete. Delete. Save. Insert. Commit. Okay, so Pete, you've answered the cost in terms of pounds. What's the likely cost to be in the storage space? Does it require lots of disk, RAM, etc.? Okay, so my answer to that is always, well, you've got this auditing requirement. You need to store this data, right? You know, whether you're using Flashback Data Archive or your own homegrown solution, you've got that storage requirement. So in many ways, I think that's an irrelevant question. You need to store this data, therefore you've got to put it somewhere. Okay, you might need to think about it for capacity planning and so on, but you're always going to have this whether you use Flashback Data Archive or your own homegrown solution. One thing to it is worth noting, when you create the Flashback archive, the data archive, you can specify some options to use compression for it. So it will compress the data for you. However, if you're going to do that, you do need the advanced compression license to enable that. So you can help reduce the storage overhead by compressing it. If you're going to use Flashback Data Archive, you will need the advanced compression license for that. You agree, but other people make the decisions on stuff like this. Yeah, I mean, it's the thing. It's just say. I mean, essentially, what it's doing is it's storing the all the row values. So when you make a change, it stores the previous value that it was beforehand, along with some of the metadata, such as versions, operations. So if you're trying to calculate, you need to look at the rate of change and see what it's doing, and then add in this overhead. 12C does have the option to actually capture a whole bunch of, bucket of auditing information, basically everything you'll get out of $SQL, things like the user, the IP address, the module, the action, all that stuff. So if you're going to capture all that as well, you've got to factor that in. But the thing is, there's no one answer for this. You've got to look at your data. You've got to know what your change rate is, what your tables you're enabling it for. And as I say, if you're going to build your own homegrown solution, you've got that requirement as well. So, if people are complaining about storage, it's perhaps they're missing the point and saying, we need this auditing requirement, we've got to deal with it. So, George Joseph. Yeah, appreciates how long a piece of string question. Yeah, you just got to test and validate on your own data, basically. At a minimum, there's these versions columns you'll get. Well, you can disable those completely, actually, but I reckon, personally, I think it's minimal use without them. There's a couple more on top of the ones I've shown here, I think. So that's fairly small. If you capture everything, obviously, that's a whole bunch of data. So George Joseph, what's the least time difference between versions that is possible? Okay, so there's two ways you can get a version difference. One is SCN, and the other is timestamp. So you can do timestamp instead. So those are time differences. One important thing to note is if you're using timestamps, it's only fully accurate down to about 3 seconds. So if you're relying on exact timings, it's not going to give you the precise information you're looking for. If you need precise information, you need to use the SCN. So these are the system change notifications. Every time someone commits and so on, database increments that counter. So this gives a complete ordering of all transactions to your database. So that you can, as far as I know, you can go down to just a difference of 1. So you can see times between any two transactions whenever they happened, and the difference between those could be almost nothing, microseconds. So using SCNs, you can get down really, really granular if you need to. Using timestamps, there's a bit of error and fudging in there. Does that help answer your question, George? Okay, so let's just rerun this query. Okay. No, I know what I was doing there. There we go. So now it's working again there, and let's just sort by this. So we can get the minimum start SCN and pass that in. So we'll find everything on or after that. And now if we run this again, hopefully this time it won't bomb up. There we go. So you can see, because these all have that version's transaction ID, I'll call them populated, which if we look somewhere, there we go, you'll see that there. It's unable to extract that information out for you. I haven't set these, or I'm capturing these, which are null. As I was saying before, by default, you just get these versions information. If you want all this extended information, they say pretty much everything out of $SQL, you need to specifically enable that. Do watch though, that will increase your storage requirements. How can a versions query return a null for the versions transaction ID? So the point is that the question is, how can we have null? Well, we ran some transactions on the table before we enabled Flashback Data Archive, so that information isn't necessarily fully captured. So that's basically the issue there. The database didn't capture it at that point, so it's not stored it in those tables, so it doesn't exist. So that's why we run into this problem. So we see versions transaction ID. And you'll see these have no start SCN as well, because we don't know when they began. Although, well, these are rows inserted before we enabled it, so we don't know when they started. Could have been, in this instance, it was only a few seconds ago, but they could have been there years before we enabled this on a table. There should be no rows at all for those transactions, rather incomplete rows. No, because we still need the previous state for, you see, they all have an end SCN. We need to say this row finished. This is the value before we did the update. but we've no idea when it originally joined the table. Could have been 5 minutes ago, could have been 5 years ago. And at the point we do an update, we then capture the current state, record the end SCN when it terminates, and then we've got further information from then on. We've got the full history from then on. So that's what's going on there. Okay. Yeah, the version, so we're talking about the transaction ID that inserted the row, Judith, and we don't know what that was. If it was 5 years ago and we've just enabled this, how do we know what that transaction ID is? Okay. Any other questions or comments on Flashback Data Archive? Just to check my understanding, enabling FBDA doesn't automatically start auditing for all the tables. Yes, that is correct, Pete. You need to alter each table that you want to be audited. So if we look up here, I skimmed over this a little bit. Where do we go? So here, first thing we need to do is create the archive. Next thing you need to do is you need to go through and alter your tables to have Flashback Data Archive enabled. So this is something you can do table by table. There may often a lot of applications have a few kind of temporary tables, scratch tables where you don't care if you audit them, or maybe some, you want to audit all your financial transactions, customer interactions and so on, but other stuff you don't really care about. So you've got the granularity. Do note, once you've enabled Flashback Archive for a table, you are slightly restricted on what you can do with it. In particular, you can't actually just drop the table, okay? So invalid DDL statement. I think there's a couple of more of the more obscure alter tables don't work as well. I think things to do with partition management don't work. I'm not sure if that's still true as of the latest release, but do note you may run into some issues. If you want to drop your tables, the first thing you need to do is actually remove it from the archive, then drop it. So something you might need to be aware of when it comes to things like your rollback scripts. First time you initialize this, or when you're deploying some new tables, your rollback script is drop those tables. So if you create a table, enable Flashback Archive, your rollback has to be disable Flashback Archive and then remove them. So something to bear in mind. Okay, so I'll hang on. I'll just go back to your point again, Judith, one last time. Okay, so let's imagine it's the year 2000. You insert a row. We have the transaction ID for that row. Okay, and now we haven't enabled Flashback Data Archive. That row stays in the database until today. 8th of November 2018. 18 years have elapsed. We now enable Flashback Data Archive for that table. We are only capturing transactions that happen from now on. That original transaction ID, when we inserted the row, is lost. It's gone. We don't know what it is. It's 18 years old. That is why there is no Now, when we now update that row, we capture its current state plus the information we have about it into that. And the transaction ID is for the insert. That's why it is null, because we do not know what it is anymore. We cannot recover it. So that's what's going on there. We did something at some point before we enabled Flashback Data Archive. Okay then. All right, so I think looks like we're drying up on questions for that. If something pops into your mind, just drop it in chat. We can always come back to this later. I will move on to the next question, which is it's kind of an interesting one. It's an interesting SQL question that's come in. So person had quite some data that looked like this. So it's kind of employee history information, and what they were showing is who reported to which manager during which time frame. So there was more data in the information they gave us, but I just restricted it down to this just for clarity. So you can see we got employee 2 reported to manager 2 from the 1st of January for the month of January. And there was a couple of other people who also reported to manager 2 in this time period. What they want to do is take this data and flip it from an employee view like we've got here to a manager view and say who reported to this manager in these time periods. So what we're going to end up with is something that looks about like this. So if we go back up, from the 1st of January until the 16th, the only person reporting to manager 2 is employee 2. Then from then until the 18th, it's employee 5. So we want a view that looks a bit like this, saying for each of these time spans, time periods, who reported to the manager? And they're asking, well, how do we do this? How do we take this and split it up like that? So let's just kind of walk through this and figure out how to do it. And we'll start by just kind of visualizing what's going on. So I always find it helpful with these kind of things to draw a little timeline picture to see what's actually happening so you can understand the flow of things. So you can see from the 1st to the 16th, employee 2 was the only person who reported to this manager. Then 16th to the 18th, we've got 2 employees. Everyone reported to them from the 18th to the 20th, and then from the 20th to the end of the month, again, it was back down to just 2 employees. So how can we split the data up like this? How do we convert it? Well, there's various techniques they can use, and they actually asked this question on Stack Overflow and got a recursive recursive query or recursive solution to this, and they were like, well, is there a better way? Is there an easier way of doing this? So I've got an alternative. Whether or not it's better, we'll come back to a bit later, but I've got an alternative way of doing this. So the first thing we need to do is actually find out what these time periods are, okay? So what we can do, in order to do that, we can take our from and to dates and we'll unpivot them into a single list of dates. So we've got one column containing all the dates, all the from and to dates, and we'll sort them, sorted by date. So we're taking these 2 dates and we're sticking them into a single date column like this. So we end up with some data that looks like this. So now we've got all our time periods here in row format. So we've got the 1st to the 16th, 16th through 18th, and so on. So we've got our individual time periods, but we want to be able to show those again as from and to columns, right? So what do? Well, we can take the values from the next row and stick it back on the current row. So we want to take the next row value and make that the end date for each one. So these are now our from and to time periods for each one. So how do we do this? Well, it's relatively straightforward. First thing we can do is just use the unpivot operator. If you're not brave enough to use unpivot for whatever reason, or you're using some archaic version of Oracle database which doesn't have unpivot, you can union them together, selecting the individual columns. But I like unpivot. It's a nice way to do it. So this will convert our 2 columns into a single column of dates. Next thing we want to do is then pivot it back again, essentially. And we can do that with the lead function. Sort values by date and take the next one, make it the end of the current one. So now we've got that, those time periods I was showing there. So next thing we need to do is actually join this into our original table. So we'll go back here. We've got our ranges. We want, for each manager, we want to join back to the original table and show all the employees who fall in this from and to time period that we've just calculated here. So this is a query a bit like this. Looks a bit scary, so we'll break it down a bit. So as I said, first thing we're doing, for each manager, we're saying for every employee who was managed by them on or before that start date, or on or after the end date, include them in that report. So this will stack up all our employees. So, that period where we've got the 18th through the 20th, we'll get all three employee rows will join into our ranges. We've just calculated that. So once we've done that, all it is then really is a matter of grouping it all together by the appropriate columns and producing a comma separated list. Just nice little easy. Hopefully you're all familiar with the list ag function. Fantastic way to create comma separated lists in SQL. So it's relatively straightforward, hopefully, way of doing this. However, there's one thing we need to cover off here still, and that is the start and end dates. So when I generated this data, all the start and end dates were entirely consecutive. So the end date of the current period is equal to the start date of the next. We just did the lead, moved it back up. So what I've done here is subtracted 1 from the end date. But this is not quite right? So if we look at the information they wanted the database to show the periods like this, well, what I call closed close intervals. So we want to have from the start date to all the dates up to, but not including the next start date. So we want to push it back to the 15th. So rather than first through the 16th and then 16th through the 18th, we're going first through the 15th, 16th through the 17th, and so on. So we need to manipulate things here. So as I said, to start with, all I did was subtract 1 from these from dates. However, this is not giving us the output that the person wanted for a couple of reasons. First up, if we go back up, we see our final row here. They want the final to date to be whatever the actual last date in that time series is. So their employee, they report to them up to the 31st of January. I've subtracted 1 from that, so we say we reported up to the 30th of January. Well, that's not right, okay, is it? So we need to kind of fudge our from and to dates here. It's a lot trickier than you might think it is. So what we can do this with some funky case expressions. And one of the things now it's kind of scary. I'll show you the SQL because we're going to talk through other approaches in a minute as well. So we need to manipulate things, both the start and the end date, to ensure they appear how the person asked them. Personally, I think it's much better if you can do what we call closed open intervals. So the from date to the 16th, so that's everything from the 1st of January up to but not including the 16th of January, and the 16th up to but not including the 18th, and so on. Questions, comments? Have I lost everyone on that one? Anything you want to know about that before we jump into the actual SQL and show how it's all working? Okay, I'm not seeing anything coming in, so I'll just show you the table data that we've got. So we can see we've got various manager rows for the manager. So we've got manager 1 has 2 employees at various points. Manager 2 has 3 employees at various points, and so on. And if we run our query like this, we can see we've now got everyone reported like so. We've got the count of how many there are and the comma separated list. Now, as I said, can the end date be made in the ranges common table expression itself? So George, you're asking can you push the end date expression into this bit here? Probably, yes, I'm sure you can. I prefer to kind of, arguably, you can actually collapse both of these common table CTEs into one. You don't need to do it as separate expressions. I tend to like to separate them out because it's easier to follow the logic and see what's going on. One of the great things about the with clause CTEs, you can just do something like this. If you're not sure, if you think something's not right in an earlier step, well, I can just say, we'll just query the dates one. So, some people like to just be really concise and stick everything all in one query and load it all together in, like a big single line as much as possible. I don't really like that. I prefer to kind of separate these things out into stages, because then it makes it easier to debug. If I want to know, have I got this unpivot right? Well, I can just query that. I want to know, have I got these ranges right? I can just query that. If I'm sticking also the case expression for making all the dates line up properly in here, well, I don't even know if I've made some mistake in this calculation. It's harder to debug. So the answer is you probably can, but personally I wouldn't. Obviously, everyone's got their own approach and thoughts on this. So we got this approach, and what this does, we've generated our ranges and then we've joined it back to the original table. And this is interesting for a couple of reasons. So as I said, they had another solution which involved recursive subquery factoring. So what this solution here is, I'm just going to talk through it very quickly, is basically generate a row for each employee for every day. So every day an employee is part of the company, there is one row generated. And they give the same results. You can argue about which query is easier to read or harder to read. Neither of them are particularly straightforward. But one of the questions is, well, which one's going to be faster? Which is going to perform better? So let's look at what happens when we get the execution plan for this. So let's get the execution plan for the unpivot approach. And if we pull this over here like this, we can see various things. So we'll look at the elapsed time. We can see we've joined the tables. I'll just pin that, and let's get the execution plan for the recursive approach. And we've got, looks much more straightforward for various reasons, but notably, we only actually access the table once. So we only query employee manager relation once, whereas over here, you can see we're querying it twice. Okay, so the original one to generate periods, and then again to join it the appropriate employees in. Another couple of interesting things to mention here. On the first glance of it, the unpivot approach does more work. So we look at this buffer gets column, that tells us how many logical IOs we did. We've got a count of 14 here, and we've got a count of 7 over here. So on the face of it, this recursive query is looking better. We only access the table once, and it does buffer gets. These are kind of two of the key things that a lot of SQL tuning people who teach SQL tuning, and including myself in this, say, look at how much work it does, how many buffer gets it does, and try and reduce extra table accesses. If you do that, then all things being equal, your query will be faster. Well, this is interesting because it's one of the times that actually break those rules. So why is that? Well, one of the things to look at here is how many data we're actually processing. So this last output rows. So with our unpivot approach, we can see at most we only ever process 22 rows. That is the maximum we are working with at any particular point in the plan. Whereas over here, with our recursive approach, well, we get up to 184 rows that we're processing. So why is that? Well, remember, for each employee, for every day they're employed, we're generating an extra row for them. So, someone who's been employed 10 years, there's going to be over 3,000 rows in that data set just for that one employee. And this leads to the query actually taking longer to run. So if we look at the last elapsed time here, we can see it's 3,600 microseconds, so 3.6 milliseconds, whereas over here we're just 600. So it's like almost an order of magnitude longer to process. We're processing much more rows and taking longer to do it. So this is why it's always to take an overall picture and how long does your SQL statement actually run for. sometimes it can perform better on some metrics, but the one that people really care about, how long does the query actually run for, it can come out worse. And so this is one of these examples where we can end up in that situation. So questions or comments on this? It's the person who asked this question actually on the call. It doesn't look like it unless they're one of the mystery people dialed in. Okay, so can you show the full CTE? What this here? So it's a recursive CTE. So you've got the base one, then it's just generating an extra date for each one, grouping them all up, list tagging them together, and this is using the Tibibito-San method approach to actually pull it out. This is, it's actually explained in detail in the Stack Overflow question. Actually, I'll just bring that out from chat, stick that in the chat. So if you're interested and want to look later, you can see the breakdown of how it works. Now, maybe there are better ways to do this. Do you really need to generate every single row a day for every employee, a row per day per employee? Maybe there's another way of approaching this. Possibly we could get some improvements there. Did want to, if you go to that question as well, you'll notice there's another solution proposed, which is this rather scary looking thing, which is got lots and lots of subqueries in here. So we can look at that and see how this comes out. You'll see we're accessing the table over and over again. There's another way to expand the days range by joining dummy query instead of doing it day by day. Yeah, like I say, I'm sure there's other ways of doing it. Can't think off the top of my head exactly how that would work. One thing I wanted to mention on here. So again, if we look at so they're saying this is a better approach. I'm not convinced. I mean, this just looks scary to me, even scarier than the other two, and it does significantly more work than the other approaches. Any other questions or comments on this? So I'll go, if not, I'll go back to Swami. I'll go back to your, address your point. The CTE is accessing the same table in the recursion step, even if it only appears once in the execution plan. Okay, I'm not sure where you're going with that, Judith, or what your point is, but okay. So if you've got questions or comments on that, just put them in the chat. I'll go right up back to the start and see the question. So we recently did a database migration from 11G to 12.2. We are facing major performance issue, but when we alter session, performance features enable 11.203, then performance back to normal. So here my doubt is why higher is giving more performance issue. What do we need to check this solution? Okay, so so first thing to remember is just generally the optimizer gets better release. We find better ways, faster ways of doing things, but there's no guarantee. Sometimes an approach can be faster in 90-95% of cases, but in these 5 or 10% of cases, it will be slower. So just because you've moved to the latest version doesn't automatically mean everything's going to end up absolutely faster. So that's important to remember. So when it comes to figuring out what's going on here, what you really need to do is look at the execution plan. So actually, we see what we're doing here, Swarmy. I'm pressing this explain plan, or no, not that one, auto trace in SQL Developer. I can see what's actually going on here. I would encourage you to run the two queries, one with the different optimizer features, and then as you can see, you can pin them. So if you don't pin them, when you run a new query, it will overwrite what's there before. And a really nice thing is you can then compare them. So you can get them side by side and see what's actually different, what's going on. So this will help guide you as to see what the difference is. And maybe it's choosing a different join method, maybe there's something else going on, but that's really your key. If you've got some queries which are running really well, and you've upgraded or made some other change and they're now performing worse, compare the two execution plans, see what's different between them, see what's going on, and see how they come out. You also got all the various stats down here. That one's highlighted in red, the ones that are different. Anything not in red is the same. So this can give you a lot of information, show you you got two versions of the same query. You're trying to figure out what's different between them or which is better. I really like this compare feature in SQL Developer. So Judith, can you share these selects? So if you go to the Stack Overflow question, Judith, you'll find the original question data and the recursive solution and this rather crazy solution I've seen. I'll put mine up there at some point soon. Okay, any other questions or comments on these queries, Flashback Data Archive? Anything else people want to say before we wrap up? Getting close to the hour now, so let us know if you've got anything else people want to ask. Not seeing anything else come in which case, I just want to thank you all for joining me. As always, I really hope you enjoyed this, but more importantly, I hope you learned something. As always, if you've got any questions or comments about this, things you want to see us cover, or things we could do better to improve these office hours and sessions, please let us know. You can put things in chat now, or you can put them, add them on the website, go to the office hours session itself. We can give some feedback, let us know how it went, what you thought, and stay tuned for more of these, and I hope to see you next time. Goodbye, and enjoy the rest of your Thursday. Cheerio.